So we're gonna try to finish up 6.5. We'll see how much we get to. But the main thing in this part of 6.5 is solving triangles. Okay. When you're solving a triangle, and I think I asked this yesterday, it means to figure out all the sides and all the angles. But what kind of triangles are we working with, like this whole week in this section?
Right triangles?
We're working with right triangles, so we already know one thing. We know one angle is a 90. In addition to knowing that you have a 90-degree angle, I have to give you two other pieces of information for you to be able to solve the problem. I can either give you the other angle and the length of one of the sides, or I can just give you the length of two of the sides. So either way, you're always starting the problem off knowing three things: a 90-degree angle, another angle, and a side, or the 90-degree angle, a side, and a side. So you always have three things to start the problem, and then you have to find the three other ones. There's no other information that I could give you to start the problem. It has to be one of those two cases. It has to be. So things that we can use as we're trying to solve triangles, we can use the Pythagorean theorem. Okay, so keep that in mind as we go through problems. And we can use the fact that all the angles in a triangle always add up to how much? 180. Always add up to 180. Yep. And something else you want to kind of keep in the background as we're solving triangles, if you can avoid using something that you've calculated, that's a good thing. Don't use something that you found to find something else. Why do you think I want to avoid using stuff that we find to find other things?
Human error.
Yeah, because if we make a mistake finding it, then it's going to mess up everything else. Okay. So we're always going to use the given. That's all we're ever going to use, what is given to us. So we focused on all 6 trig functions yesterday. Today, when we're solving triangles, we're only going to use these 3. The reason we use those 3 is that's the 3 we have buttons for in the calculator: sine, cosine, and tangent. So you're going to have to decide which trig function that you need to use. And the way you can figure out which one you need is you're usually going to have a side that you're trying to find. You're going to have a side that you already know. You have to figure out what those two sides are called. Maybe they're opposite and adjacent. Maybe it's hypotenuse and adjacent. Whatever two sides you know, that's how you pick the trig function to use. So if you know the opposite and you're trying to find the hypotenuse, that's the sine function, because sine is opposite over hypotenuse. Okay, but it's always going to be one of those 3 for today. And really, that's pretty much all you need for kind of the background on how to solve triangles. Okay, so now we'll try solving the problem. Okay, so in the first one, they are giving us an angle and a side. So they're telling us that one of the angles is 37, and the hypotenuse is 8. Okay, does everybody have the part above the solve? All right, so first thing I'm going to do, this is really just to kind of set up and organize all our stuff. Let's put the three sides, right up, going down like that. And then we're going to put the three angles. Like that. I don't need a name for the last angle as a Greek letter because I already know what it is. It's 90. The angle across from C is always just the right angle. So we know that. Let's draw it out and see if we can use our sketch to fill in our table. Okay, we've got a 90. We've got one angle that's 37. It doesn't matter where you put it. The 8 does matter. The 8 has to be across from what? Yeah, that has to go there. Okay, so we've got our diagram filled in with what was given. Now let's label it and see if we can fill in our table. Let's call this side A, B, C. And what's the Greek letter we use for the angle that's across from B? Yeah, beta. And what's the Greek letter we use for the angle across from A?
Alpha.
Alpha, good. Okay. Now fill in everything you know. Do we know A in our triangle? Nope, so I'm going to put a box around it because I need to find that. Do we know B? No. No B. Okay, do we know C? Yep, C was given. Okay, do we know alpha? Yeah, what's alpha? That's 37 degrees. And we don't know beta. I could say beta wasn't given to us. And then there's the right angle. All right, when you're solving a triangle, you can find anything you want first. I usually get the angle done right away. How can we get the angle? Yeah.
37 plus 90 minus 180.
Yeah, so 37 plus 90. Add that up and subtract it from 180. Or the same thing is just subtract 37 from 90. That's the same thing. So if alpha is 37, what does that mean beta has to be? 53. Yep. Now that we have that as 53, we're going to forget about it. Okay, don't use the 53 to figure out A or B. Because if it's wrong, it's going to mess up everything else. Any question why it's 53? Okay. All right, so that's beta. Now let's find A. Okay. What we want to do now is name the sides. And by name them, I mean tell me what position they're in. The choices are going to be opposite, adjacent, or hypotenuse. 37 is going to be the angle we use because it was given. Don't use the 53. So what's the name of side A from the perspective of 37?
Opposite.
Yep, it's opposite. And what position is side B? That's adjacent. And side C is that's the hypotenuse. Okay, so we want to find A. A is the opposite, and we know the hypotenuse. So which trig function out of sine, cosine, and tangent has opposite and hypotenuse in it? Sine. Yep. So this is how you set it up. It's the sine of, and that's not multiplication. Okay, when you put parentheses, what's here is the argument. It's kind of like when you type like log 12. It means you're taking the number 12 and you're filling it into the log function, and that's going to give you an answer. So we're going to take the sine of 37 degrees. So we're going to fill 37 into the sine function. The calculator is going to give us the answer. And remember, sine is opposite over hypotenuse. Okay. What's the opposite in our picture? A. And what's the hypotenuse? 8. A over 8. Right. Now we're going to solve for A. How do you get A by itself?
Multiply by both sides.
Multiply both sides by 8. That's gone. And there you go. Okay, we have to type that in, and we're going to round it off. Can someone read to me, what does it say in that box? 8 times what?
Sine 37.
Sine of 37 degrees. Okay? So because we're doing this in degrees, we cannot be in radians. Okay. So go to mode, put in degrees, and then type in 8 times the sine. And what are you filling into the sine formula? The number 37. Okay, so that means A is about 4.815. 4.815. All right, so now we know 2 out of 3 sides in the triangle. What theorem could you use to find the third side now that you know 2 of them? You could, but why do you think I'm going to say that that's not a good idea?
You don't want to use values you found.
Because what?
You don't want to use values you found.
Yeah, we don't want to use the values that we found. If that 4.815 is wrong and you use it, well, now you got B wrong. So we're going to find B going back to the information that was given. Okay. Right, so let's find B. All right, so this time you're still using the 37. But now you're going to focus on B and the side that was given. So B is the adjacent. The given is the hypotenuse. Which trig function has adjacent and hypotenuse in it? Cosine, yep. So it's the cosine, and then you always fill in the angle that you're using. 37 degrees. So cosine 37 degrees, and cosine is adjacent over hypotenuse. B divided by 8. It's a pretty similar equation to the last one. How are we going to get B by itself? Times it by 8. And that should be your answer for B. Right, so 8 cosine 37. So 6.389. Okay, we'll generally do 3 decimal places. 6.389. Now, if you had extra time and you wanted to double check your answer, you could try a squared plus b squared and see if it comes out to about 64. Okay, it should. If you did it right, it's probably going to come out to like 63.99 or something.
64.003546.
64.00. Okay, so close. It's not exact because we rounded. Yep. All right, and that's how you solve a triangle. Where they give you a side and an angle. Okay, any question on that one? Now, they didn't tell you what the 37 was. Okay, we decided to call it alpha. In this one, they're telling you. Okay, you don't have a choice what the 20 is. You can't say, oh, maybe I'll make the 20 beta. No. Alpha is 20. Okay, they're telling you. Okay, so the diagram is really just so you can see what's across from what. All right, so you can kind of visualize it. After you do a lot of them, some people can just kind of visualize it in their head. They don't need the diagram to see it, but at first you might. So here's your diagram. Okay, that's just generic, nothing filled in. Now, fill in what you can. So alpha is 20 degrees, and A is 12.3. All right, so off to the side, I'm going to make my table. Okay, so A, they give me 12.3. Do they give me B? No. So I need to find B. Do they give me C? Nope. So I need to find C. Do they give me alpha?
Yes.
Yeah. Alpha's 20. And do they give me beta? No. They don't give it to me, but I can find it pretty easily because they all have to add up to 180. So what does beta have to be this time?
70 degrees.
Yeah. So beta is going to be 70. I'm not even going to fill that in on my diagram. Because if I don't fill it in on my diagram, then I won't be tempted to accidentally use it. Okay, I'm only going to use the circled stuff. Because that's what was given. Okay. Any question on how we got beta? All right. Now, let's do C first. Just to show you, it doesn't matter what order you do it in. Okay, now you need to know the positions of the different sides. Everything is from the 20. So what's side A?
Opposite.
That's going to be opposite. And side B? So we were in the middle of finding C. C. We're doing C. And we had just figured out that A was the opposite. I don't think we labeled C yet, but it's across from the 90. So what's C? It's the hypotenuse. So this time we want to find C. So we need a trig function that has hypotenuse, and the one that we know is opposite. So what trig function has opposite and hypotenuse? Cosine is adjacent and hypotenuse. Sine. Yep. So you can always start to set it up just like that. Okay, fill in your angle here. Okay, what's our angle? 20 degrees. And then the opposite is how much? And the hypotenuse? C. Okay, a little bit different because now the variable is in the bottom. Okay, so when the variable is in the bottom, the first thing we do is multiply both sides by C. What that does is it at least cancels it from there and puts it over there. Okay, so now we have C times the sine of 20 plus U equals 12.3. And now, how are we going to get the C by itself on the left?
Divided by sine.
Divide by sine 20. And divide by sine 20. So the sine 20, that cancels. And you get 12.3 over sine 20. So if you look at what you had originally, this is what you had originally. What ends up happening is the sine 20 and the C switch places. And that's the shortcut I'm going to use from now on, instead of going through that work. Just take the letter that's in the bottom, only if the letter is in the bottom. If the letter is in the top, we did that in the last problem. That's a little different. But when it's in the bottom, just switch it with what's on the other side. Right, and then type that in and see what you get. So 12.3 divided by sine 20. So it's about 35.963. 35.963. Let's see. Don't put a degree symbol on that. That's what I almost did, but it's a side. It's not an angle. All right, and let's finish it up with B. Okay, what? Not the name, but what position is side B?
Adjacent.
It's adjacent. And what's the side that we were given?
Opposite.
Opposite. Opposite and adjacent. What trig function has those two things?
Tangent.
That's tangent. Yep. So tangent, leave room for your angle, and then leave room for your fraction. Okay. What's the angle that we're using? 20 degrees, because that was given. Opposite over adjacent. Okay. What's the opposite? 12.3. And the adjacent? B. That's what we're trying to find. Okay. Is the letter in the bottom?
Yes.
Yeah, then I can use the trick of just switching the left side and what's in the bottom. So B equals 12.3 over tangent 20. Okay, and I'll leave that for you to plug in and you can see what it is. All right, any questions on how we got B? Okay, so both of those problems, they started you off with a side and an angle. The last one we're going to do for today gives you two sides. Okay, so this will be the last one that we do. Okay. What do you think the first thing we should do with this information so we can kind of see this problem a little better?
Try.
Yeah, let's try it. So that we can see like what's opposite, what's adjacent, and so on. Okay, what's one thing that they tell me?
Hypotenuse.
Yeah, and they don't tell me necessarily, well, they do tell me which number is which. You have a 6.1 and a 12.7, and one of them is the hypotenuse. Which one does it have to be?
12.7.
It's got to be the big one, right? So that's 12.7. And then one of the other sides is 6.1. Doesn't matter where you put it. Let's put it right there. All right, so now we'll solve the triangle. Label your sides. A, B, C. The angle across from A we call alpha. Angle across from B, beta. And now let's make a table and see what we know and what we still have to find. Okay, do we know A? Yes, we do. 6.1. Do we know B? No. Do we know C?
Yes.
Yep. Do we know alpha? No. Or beta? No. So we don't know either ones of those. All right. Let's find B first. How could we find B using something we've talked about before? And I'm okay with you using it this time.
I thought you were in zero.
Yeah, why am I okay with it now, but I wasn't before?
Because you have two givens.
Right. I'm not plugging anything in that I solved for. When I use Pythagorean theorem to find B, all of it is given. So we got a squared plus b squared equals c squared. Okay, can someone just tell me what's 6.1 squared?
37.21.
So 37.21 and 12.7 squared, like 160 something. 161.29. Now I need to subtract 37.21 from that. What's 161? 124 point, what is it? Oh, 08?
Yes.
And the last thing I need is the square root. Technically, this is approximate. I should not use equal, but it's okay. What's the square root of 124? About
139.
11.139. Okay, so that's B. Right, any question on how we got B? Right, so now let's find alpha. Okay, remember, you're using the two sides that you know. So we're doing alpha. So we need to name the sides. What position is side A? Opposite. And side B? Adjacent. Opposite and adjacent. Which trig function is that? Tangent. Yep. Tangent. Leave room for your angle.
Shouldn't we not use values that we calculate ourselves?
Can we use sine?
Yeah, you're right. We shouldn't be using the value we calculated. So let's, instead of using those two, yeah, we should still use this one. But we should probably use this one. Good idea. I missed that. So instead of tangent, what trig function would has opposite and hypotenuse? Yeah. So let's do sine. I mean, I'm pretty sure B is right, but let's do sine. Okay. What's our angle that we're trying to find?
Alpha.
Alpha. And this is the first time we've ever had the letter on this side. It's usually been in the top or the bottom of the fraction. Okay. Now, side is opposite over hypotenuse. Okay. What's the opposite? 6.1. And what's the hypotenuse? 12.7. Now, we have to get alpha by itself. Alpha is inside the sine function. When something is inside parentheses in a function, you can't add, subtract, multiply, or divide. You have to cancel this function out. Just like if you had this. Actually, let me write it like this. You can't add, subtract, multiply, or divide to get rid of the exponent of 2. The only way to get rid of an exponent that is squaring is the opposite of squaring, which is square rooting. So same idea here. We've got to get rid of the sine function with the opposite of sine. Does anybody know what function cancels out the sine function? Yes?
Arcsine.
Yeah, it's called arcsine or inverse sine. Okay, so that's what we have right now. Sine alpha equals 6.1 over 12.7. And to cancel that out, you can do the problem different ways. That's why I have to adjust the notes. We need to cancel out sine, and we use what's called inverse sine. Bless you. Or I think Abe, you said arcsine, right? And that's the same thing. On a calculator, you're probably going to see the sign to the -1 button. Arcsine, I think that's an older way of saying inverse trig, but it means the same thing. And if you ever have to cancel out the cosine function, you use the inverse cosine function. And to cancel out the tangent function, you use the inverse tangent. We have buttons for all those on the calculator. I'll show you where they are. Okay. I generally stick with writing it those ways. It's a sign with like a little -1 up higher. That -1 is not an exponent. It just means inverse sign. Okay, so what we have to do at this step is very similar to what you do at this step. The word you want to say is take. Like in this problem, I would take the square root on both sides. In this problem, I'm going to take the inverse sine of everything that's on the left. Then I'm just going to kind of squeeze it in. Take the inverse sine of everything that's on the right. When you take the inverse sine of the regular sine, it's like taking the square of the square root. They cancel out. And the only thing you're left with on the left is alpha. And anybody know how you type in inverse sine on the calculator?
Second sign.
Yep. Press second. Press sine. Okay, so to finish up that last problem where we're finding the angle, we were just about to take the inverse sine on both sides. Inverse sine and regular sine cancel each other out. And now on the right, we have to do the inverse sine of 6.1 over 12.7. So that gives me an angle of 28.706. And don't forget your degree symbol. Okay, so let's go write that in our table up above. So 28.706. And now, technically, you could find beta by just subtracting that from 90. But the downside is if alpha is wrong, then you're going to get beta wrong doing it that way as well. Okay, so I'll finish this up by finding beta. Same way we did alpha. Now, this time, we're using beta, so our perspective in the triangle is going to switch because we switched our angle. Because we switched our angle, the names opposite and adjacent no longer apply to those sides. Now, everything is from the perspective of beta. So now, this side is opposite, and this side is adjacent. So let's finish it up and find beta. Stick with the two sides that were given. So now we're using the adjacent and the hypotenuse. And that trig function is cosine. We're solving for beta. So fill that in for your angle. And now put the adjacent in the top and the hypotenuse in the bottom. So the adjacent is 6.1, and the hypotenuse is 12.7. It ends up being the same fraction we just had up above, right there. Okay, same fraction. All right, so beta is inside the cosine function. So we need to get rid of cosine by taking the inverse cosine of what's on the left, and we're going to take the inverse cosine of what's on the right. Inverse cosine and regular cosine cancel out, and we get beta equals the inverse cosine of 6.1 divided by 12.7. So it's 61.294. Okay, let me go up to the table. And one thing we can do to double check it is make sure that those two angles add up to 90, because we already have the right angle, so those two have to add up to 90. So 28.706 plus 61.294. Again, this is just double checking. Yeah, perfect. We got exactly 90 degrees, which is a pretty good indication we did it correctly. So just as a reminder, we will finish this section tomorrow, so we may not have as much of a review day, but that's okay. All right, so let me put up the homework, and I am going to adjust this. Okay, so the homework will be 25 to 32, 40 to 42, and 45. So on 25 to 32, let me give you a hint. You need to use inverse trig to solve. So those are all just quick problems you need to plug in on the calculator with inverse trig. 40 to 42 and 45, those are on solving right triangles. So there'll be 2 like we did at the beginning of class, and then there'll be 2 like we finished up towards the end of class. All right, and we can go over any questions that people have, because tomorrow is supposed to be the review day, so we'll finish up this section, and hopefully you'll still have a little bit of time left at the end of class to start the review.